Question 1. Three events A, B and C are such that the probability of B is 1/5, the probability of C is 1/6, the probability of A union B is 3/4, probability of A union C is 5/6. We know the events A and B are independent. We want to find the probability of A. So a Venn diagram is probably going to be the best way forward to help represent this. So let's look into this. We have three sets in the question, so if we draw three overlapping sets, we could look into this idea. We know the probability of B is 1/5, so everything in B is 1/5. Everything inside of C is 1/6, the probability of C is 1/6. We know something about A union B, all of A and all of B. And we know something about A union C, all of A and all of C. But everything is quite complex here. But we know that A and B are independent, so probably this is looking at things in a method that is too complicated, so we want to simplify it and just consider sets A and B. So now we're only considering sets A and B. We know A union B is 3/4. Everything inside of A and B is 3/4, which means everything outside is 1/4. So let's put that on the diagram. So 1/4 is outside of A and B, A union B, everything in here, so 1/4 there. We know the probability of B is 1/5, so all this region is 1/5. We've also got 1/4, so if we add 1/5 and 1/4 together, the rest of the probability to make up 1 will be A only, so we can work that out. So 1/5 plus 1/4 is 4/20 plus 5/20, which is 9/20, which means the region A only is 11/20. So 11/20 is this moon-shaped area here, 11/20. So let's now call the intersection of A and B X. So the only region we've got missing is B only, this moon-shaped area here, and this must be 1/5 minus X. So this region is 1/5 minus X. But we know that sets A and set B are independent, so the probability of A times the probability of B equals the probability of the intersection of A and B. Probability of A times the probability of B is probability of A intersection B. We know the probability of A is 11/20 plus X. We know the probability of B was 1/5. And we know the probability of A intersection B is X. So let's put that in. 11/20 plus X times 1/5 equals X. So let's solve this equation. 11/20 times 1/5 is 11/100 plus X times 1/5 is X/5 is equal to X. And then if we subtract X/5 from each side, this is 5/5 minus 1/5. So we have 11/100 equals 4x/5. So x is 11/100 times, we need to invert that fraction, 5/4. And if we work that out, it'll come to 11/80. We want the probability of A, which is 11/20 plus X, so it's 11/20 plus 11/80, which is 11/16. Part B, determine whether or not A and C are independent. This is going to mean we work in the same premise. Let's just consider A and C. We know something about the union of A and C. We know the probability of C, and we've just found the probability of A. So if we draw a new Venn diagram and work from there, probability A union C is 5, 6. So that's everything in A and C. So the outside region is 1/6. So let's put 1/6 on our diagram. The question tells us the probability of C is 1/6. We already have 1/6, so the probability of A only, this moon shape, is 4/6. So 4/6 goes on our diagram. If we call the intersection of A and C y, we know that 4, 6 plus y is the probability of A, and we already know that that was 11/16. So 4, 6 plus y is 11/16, so y is 11/16, and that is equal to 1/48. So we can put 1/48 on the diagram, and we can calculate what C only is. So if we call the C only region Z, 1/48 plus Z is the probability of C, which we know is 1/6 from the question. So Z is 7/48. So part B of the question says determine whether or not A and C are independent. The probability of A times the probability of C is 11/16, so we got earlier for the probability of A, and the probability of C we know is 1/6. So if we times these together we get 11/96. But we know from the diagram the probability of A intersection C is 1/48. So the probability of A times the probability of C, does it equal the probability of A intersection C? Well, 11/96 is not 1/48, so A and C are not independent.
Venn diagrams are great for doing probability questions. It means that we can perhaps get a feel for what's going on. It's worth mentioning, however, that a question like this can be done just using formulae. So for this question, we know that A and B are independent, which means that P of A times P of B is equal to P of A intersection B. That comes directly from the definition of independence. We also have the main formula which connects all the probabilities, and this one is on your formula booklet should you need it. Hopefully you'll have done enough practice to know it. Just a quick note about the independence formula. On your formula book you have PA intersection B equals PA PB given A. Now, given that is a conditional probability, and you'll meet that properly in A2, but in terms of remembering the formula that we're using here, if you can just remember that this means B given A, so that's given that A is happening or has happened, then if they're independent, the probability of B doesn't depend on A, which means this can be ignored in the case of independence, and that then directly gives you the relevant formula. So, in this question, the first part, we're wanting the probability of A. So, do we have enough information to pop into these formulae in order to find that? So, let's have a look. We know what P of A union B is, that's 3/4. We don't know what P of A is, obviously, because they're asking us to work that out. The probability of B is 1/5. And by replacing PA intersection B by PA times PB, we get PA times 1/5 here. So that's using this formula to change this into this. Okay, so carrying on from there, we can see now that we only have PA involved, so we can solve that. We need to take 1/5 from both sides, so we have 3/4 take away 1/5 is equal to P of A. Now we have one of them, and then we have to take away 1/5 of that. So that means we have 11/20. You can do that by calculation or using a calculator. PA times 4/5, and therefore PA is equal to 5/4 times 11/20, and that gives us 11/16. Those two cancelling like that. For part B, we're determining whether or not A and C are independent. So the question boils down to, is it true that P of A times P of C is equal to P of A intersection C, or A and C? So what do we know? Well, we can write out the main formula. A union C is probability of A plus the probability of C, take away the probability of A intersection C. And in fact, we can write this way around, because if we add the intersection to both sides and subtract the union, then we end up with this. And we know all the numbers we need for this. P of A, we've just worked out, was 11/16. P of C is 1/6. And the P of the union of A and C is 5/6. And that comes to 1/48. So in the thing we're trying to find out, which was this, and I should have put a question mark there, we now know that the probability of the intersection is 1/48. And now we can work out the multiplication, so PA times PC is 11/16 times 1/6, and that is 11/96. So we now have, is it the case that 11/96 equals 1/48? Well, no, it isn't. And so we conclude they are not independent. So that's a way that you could answer the parts A and B of this question. The advantage of Venn diagrams, it does give you more of a feel for what's going on overall with the probabilities. And so it's certainly at least worth practicing with the Venn diagram, maybe in conjunction with doing it in sort of straight, using the formulae method.
Part C. What can be said about the events B and C if B intersection C is the empty set? If B intersection C is the empty set, then there is no overlap of the sets, and the sets B and C are mutually exclusive.